All right, students, so you're gonna take notes on this video. I wanna just kind of go over uh, graphing and transformations. Remember, we talked about the idea of a parent function and a child, how the child would kind of resemble the parent, just like in real life, children resemble their parent, but they don't look exactly like their parents. So let's talk about function transformations. So on your notes from C43, there's a note guide right here. Remember, I had this on the screen last Thursday. We took notes, and I had you put this on your screen while you're paying attention to me. So let's go over each one of these uh, transformations. Notice they're called transformations, right? Um, okay, so the word transformation. So a function transforming into a different function. It looks the same, but it resembles the original, but it's not. And there's 5 types of transformations: a horizontal translation, vertical translation, reflection, horizontal stretch or shrink, and a vertical stretch or shrink. So let's go over each one real quick. Um, so let's think of a square root function. We'll use a square root function as our guide. Okay. So let me bust out the graphing calculator. So here's a graphing calculator. Let me type the parent function of a square root, the square root parent function. Check this out. F of x equals the square root. Move my mug over here so I can get the square root here. Square root of x. Okay, there's the parent function. Look what I'm going to do now. I'm going to create a child now, a child function that looks like the parent, but it's not going to be the parent. What I'm going to do is I can either subtract something from the x or add something to the x. As long as it stays within the square root symbol, then it's going to move to the right or to the left. And that's what horizontal means. So the graph shifts left or right. So let me make a child function. Let me add 3 to the x, and notice how it'll move 3 units to the left. Check it out. Go back to the graph. Let me copy and paste this puppy. Copy, paste, but let me add 3. Check it out. Plus, let me make sure it's within the square root symbol. Plus 3. Notice. Look what happened. This is a horizontal shift. The parent is in red. We shifted horizontally 3 units. Okay, so when we add something, it goes to the left. If we subtract, it goes to the right. Watch, look, let me go back over here. What if I put subtract 3? If I put a minus 3, look at how it would shift to the right. There you go. There's subtract 3, and here's adding 3. Notice that. Okay. So that's horizontal shift. What if I wanted to translate it up or down, move it up or down? Well, here's where I would either add something or subtract something outside the square root now. Notice that. So here we do it within, it's f of x minus h, where you're taking some number and you're adding it or subtracting it to the x. But now over here, we have the whole function, and now we're going to add some number k outside the square root symbol. Notice, it's outside it. Okay? So f of x represents the function square root of x. But now, if we add something outside the square root itself, notice how it's the 7 or the 1 as examples, they're outside the square root. That's going to make it go up or down. Check it out. Let me go back to my graphing calculator. So let me go ahead and erase this. And now let me add a 3 outside. Look at plus 3. Look at it went up. If I subtracted 3, it goes down. So that's a vertical translation. Vertical translation is up or down, horizontal is left or right. And all it depends upon is whether you're going to add those numbers. If the numbers you add or subtract, are they going to be inside the square root symbol or outside the square root symbol? If they're outside, it's going to move it up or down. If they're inside the square root symbol, you're moving horizontally, left or right. Okay? How about reflections? Now, if you put a negative something right in front of the x, it's going to be flipped over. Look at the graph flips over the x or y axis. If it's right next to the x, the negative, it's going to flip over the y axis. Let me show you. So let me come over here. Let me erase the 3. Let me put a negative right in front of the x. And notice how the blue graph is going to be flipped over the y-axis. Now, when I say the y-axis, that's the vertical axis. Notice how if I put a negative right in front of the x, it's going to be flipped over the y-axis. Look at there it is. So we took the parent function and we flipped it. We reflected it over the y-axis. Okay? But what if I reflected it over the x-axis? What do you have to do to reflect a graph over the x-axis? Well, look at the note says, your note guide. Put the negative outside the function. In other words, put the negative, look at this, outside that square root symbol, and it's going to flip. It's going to flip over the x-axis now. Instead of flipping over the y-axis, left or right, it's going to flip over the x-axis if I put the negative outside. Watch. Okay, I'm going to put the negative outside right here, and watch the graph flip over the x-axis. Boom. There it is. Okay? So, negatives outside the function, negatives outside the whole function is going to flip it over the x-axis. Negatives inside the function, where the x is at, is going to flip it over the y-axis. Cool. What's the next one? Watch this. Horizontal stretch or shrink. So horizontal means left to right. So let's focus now on the last two. Here you got to really pay attention here. Okay, horizontal stretch or shrink. If I multiply by some number the x, look at, so here I multiplied by 3, this example, they're multiplying the x by 3, then it's going to shrink by a factor of 1/3. Okay? It's going to shrink by a factor of 1/3. So horizontally shrinking something, to shrink horizontally means horizontal means left to right. So you're shrinking. This is shrinking horizontally. Stretching horizontally is this way. Okay? Shrinking vertically is this way. Stretching vertically is this way. Okay? So horizontal means left to right. So horizontal, shrink, the graph will start compressing. That's shrinking horizontally. Horizontal stretch is going to be stretching this way. Watch what happens. Check this out. All right, so check it out. The next one is, let's take that parent function and multiply it by 3. Notice when you multiply it by 3, it shrinks what they call by a factor of 1/3. That means every x coordinate is going to be multiplied by 1/3, which is the same as dividing by 3. So every x coordinate on the parent will actually be multiplied by 1/3. So the child function will be, it'll shrink. Notice, it's going to shrink by a factor of 1/3. That means every x value in the parent is multiplied by 1/3. Let me show you what I mean. Let me put a 3 right here, and look at the blue. The parent is in red, and the blue is kind of like, it's almost like you took that graph and you're kind of like smashing it against the y-axis. So here's the y-axis, the vertical y-axis. Imagine shrinking it. It's getting closer. It shrinks toward the y-axis. Notice that. It stretches away from, or shrinks toward the y-axis. So here, I put a 3 in front of the x, and the blue graph it's kind of shrinking towards the y-axis. Imagine taking the red graph and kind of smashing against the y-axis, that's what's going on. We call this a horizontal shrink. And look what happens here. Let me pick a point here on the parent function. Look at like 4, 2. Where on the blue function was the y coordinate 2? It was right over here. Look at how the y coordinate is 2 right there. So I can hone in on it's about right there. There's a y coordinate. It's almost about 2 right there. Notice how the x coordinate is 1.3. What happened is that the 4 right here at 4, 2, if you take the x coordinate and multiply it by 1/3, just the x coordinate, not the y. Because notice the x right here on the function right here is being multiplied by 3. It makes, you take every x, what ends up happening is that every x coordinate on the original parent is multiplied by 1/3, which is the same as divided by 3. So 4, 2, the point 4, 2 on the original, imagine taking the x coordinate and dividing by 3, it becomes 1.3. And look at right here at 2, look how the x coordinate is about 1.3. So it's like smashed. So what we say is this blue graph has been horizontally shrunk by a factor of 1/3. Even though it's a whole number 3, the way we articulate it, it's a shrink by a factor of 1/3. But let me multiply it by 1/2 now. So let me go back and change the child function, which is blue. What if I put a fraction in front of the x? Watch what happens. Now what happens is a horizontal stretch. You see? We stretched it horizontally. Okay? And so if we stretch it, so remember the red was the parent, the blue is the child. Imagine we took the red function and we're stretching it away from the y-axis, and that's why it looks thinner. We're stretching it, so it's going to be a little more, not as steep. If we stretch it away from the y-axis, it's going to get like that. So that's why the blue is shorter now. So look at that point 4, 2 now. Imagine multiplying 4 by a factor of 2. Well, it's going to be right here at 8. Look at 8, 2. 4, 2 on the parent became 8, 2. Because we stretched it. We stretched it horizontally. 4, 2, we took the x coordinate. Notice, where are we at here? Right there. Right there. 4, 2 became 8, 2. Notice right there. Okay? So that's why when we talk about this kind of transformation, even though it's a fraction, notice the note guide right here, even though this is a fraction, okay, it's a fraction of 1/2, we say it's a stretch by a factor of 2. And if it's a whole number, we say it's a shrink by a factor of 1/3. Okay, so the way to memorize it is just, look, if it's a whole number, just take that whole number, make it into a fraction of with 1 on top on the numerator. So if this was a 4x, imagine it being a 4, then it'd be a shrink by a factor of 1/4. Okay, if this says 1/4 x, this would be a stretch by a factor of 4. So it's like the opposite. You take the reciprocal, just reciprocate. In other words, okay. That's basically what you do. How about vertical stretch or shrink now? Notice the difference now. A vertical stretch or shrink, let me get a blue marker. Vertical, so that's up and down. A vertical stretch or shrink, notice what we're doing is we're taking the function and we're multiplying by something outside of it. Here on the horizontal, we're multiplying by a fraction or a whole number inside the square root. But what if the number's outside the square root? Notice it's going to be a vertical stretch by a factor of 4 and a shrink by a factor of 1/5 if it's outside. Notice, if it's outside the square root symbol. In other words, if it's outside, we're dealing with a vertical stretch or shrink. In other words, it's going to get farther away from the x-axis or more closer to the x-axis. Okay, farther away or closer. So, let me demonstrate. Let's do the last two examples here. Watch. Let's go ahead and multiply by 4. We're going to have a stretch, a vertical stretch by a factor of 4. Watch. So that we already have the parent in red. Let me multiply the whole function outside the square root by 4. And look what we got. We have a vertical now. We have a stretch. In other words, this function is now stretched away from the x-axis. Okay, we took that red parent function and we stretched it away from the x-axis, so we call this a vertical stretch by a factor of 4. What about if it was 1/5? Then it'd be a shrink by a factor of 5, notice. So let me do it outside. So remember the horizontals were if you put the whole number of the fraction and multiplied by x inside the square root. Now what we're doing is outside the square root. What if I multiply the whole square root by 1/5? Watch what happens. So now it's a vertical shrink. It's getting closer. We took that parent and now it's getting closer to the x-axis. Vertical shrink. Okay, by a factor of 5. Let's go ahead and do a few examples. Okay, let's do a few examples. So on your paper, go ahead and write down this first example. Describe the transformation of f, that means the function f is right here. Describe the transformation of f represented by g. So you have g of x is a new function. Let me underline in red. So here's g of x in red. What took place from the parent? Look at the parent, f of x equals the square root of x. That's the parent function. That's just a simple square root function. That's the parent function. What happened from the parent to the child is what this is going with, what's being asked. So we're going to describe it in a few sentences. So I see, look at the parent functions, just square root of x. Look at, there's a number multiplied outside the square root symbol, and there's a number subtracted inside the square root symbol. So that looks like we're dealing with a horizontal translation of sorts, and there's a number outside the square root being multiplied, so that's going to be this case here. That'll be right here, right? So we're dealing with a vertical stretch or shrink and a horizontal translation. Okay, so let's see. Let me graph them. So let me graph the parent. So the parent's already graphed in red, so let me graph now the child. We copy and paste. So for this assignment, you're definitely going to want to use a graphing calculator because it makes life easy. Where are we at here? Here we go. So where's that example? So 4 times the square root of x minus 2. So I'm graphing the g of x now, right? Right. Let me make this g of x. G of x. 4 times x minus 2. Remember, the minus 2 has to be inside that square root symbol. So look at that. So what do we got? We have, so the parent function, we ended up scooting it over to the right horizontally 2 units, right? And that's precisely what our note guide says. If it's going to be subtracting some number, then it's going to be to the right, 2 units to the right. So we could definitely see that from the graph. From red to blue, it's scooted over 2 units to the right. And then there is a vertical, look at the numbers outside the square root, so there's a vertical stretch or shrink. Let's see. It looks like a vertical stretch by a factor of 4. Okay, so if it's a whole number, then it's just by a factor of that whole number. The horizontal is the one that gets tricky. If it's a whole number, then it's by a factor of its reciprocal. If it's a fraction, then it's still by a factor of its reciprocal, which becomes a whole number. So the horizontal gets tricky, but the vertical, that's pretty straightforward. So let me erase all my chicken scratch here. So we're dealing with a stretch by a factor of 4, a vertical stretch, right? We took that parent function, we vertically stretched it. So we're taking it away from the x-axis. It's moving away from the x-axis. Look at what it says here. The graph stretches away from or shrinks toward the x-axis. So we're stretching it away. The x-axis right here, we took that and we're stretching it away from the x-axis. So it's a vertical stretch. So here's the answer. Let's go back. Watch me type it in. So this is a horizontal shift 2 units to the left, or right, 2 units to the right. Okay, that's one transformation, and it's a vertical stretch by a factor of 4. Okay, that's the answer. This is how we describe it. So this is the answer. So describe the transformation. I described it right here in 2 sentences. It's a horizontal shift 2 units to the right, and we saw that. Look at from red to blue, it's 2 units to the right, and then a vertical stretch. Remember, stretched away from the x-axis by a factor of 4. Cool. Let's try a second one. One more. Here we have a cube root function now. Okay. Describe the transformation of f represented by g. Remember, f is just the name of the function, and g is the name of the child function right here. Okay, so here's the parent function of a cube root. So let me go ahead and change that on our graph. Let me make this into a cube root function. There we go. F of x equals cube root. Remember, go to functions, go to miscellaneous, and you'll have the nth root, so you can make the cube root of x. There we are. It's in green. The parent is in green this time. There's a parent function. Cool. Let's do g of x now. We got some things going on. We have 5 being subtracted inside the cube root, and then 1 being subtracted outside the cube root. So there's 2 things going on. In other words, I got something being subtracted outside the root, so I know it's going to be a vertical translation. Translation is just a fancy word for shift. And I also have something being subtracted inside the cube root, so I know it's going to be horizontal. So there's going to be some horizontal movement, left or right, and some vertical movement, up or down. I already know that because there's a number being subtracted inside and a number being subtracted outside. Here we go. So let me go ahead and graph this. -5, -1. So let me copy and paste this puppy. Copy, paste. So the child will be in purple. So inside the cube root was a -5. Outside was a -1. Look at that. So what ends up happening is the -5 shifted it to the right from green to purple, 5 units to the right. And this point ended up coming down 1 unit. That's what the -1 does. The -1, this went down 1. Notice, it went down right here. So this point became that point. Notice, right there. So we end up going 5 units to the right and then 1 unit down. That's the shift. That's the transformation. So let's go ahead and type that in. There we go. Horizontal shift, describing the transformation now from the parent to the child. Horizontal shift, 5 units to the right. And a vertical shift, 1 unit down. Done. And you see it right here. 5 units to the right, 1 unit down. From green to purple, 5 units to the right, 1 unit down. Let's do one more and we're done. You guys are doing awesome. And here we go. All right, here we go. So we have the cube root function, not cube root, fourth root function. Here's a parent function, the fourth root. Okay, that's f. Now what takes place here? Here we go. We have something being subtracted within the fourth root. We have something being added outside the fourth root. And we have a negative 1. Remember, there's really a negative 1 there, even though we won't bother to write it. There's really a negative 1, a negative being multiplied by the whole thing. So I'm looking at my notes. Let's see what we got. We got stuff being added or subtracted. Right, let's see. We have stuff, first of all, we have the negative symbol. Right, so I already know, and it's outside the function itself, so I know it's going to be this case. Look at the negative symbol's outside, so I know it's going to be a reflection over the x-axis for sure. What else do we got? We have a number being subtracted inside the root symbol. So inside the root symbol, I know it's going to be this kind of case. It's going to be a horizontal translation. And then I got a number outside being added outside the square root symbol. So I know that it's going to be a vertical. So look at something being added outside. So I know it's going to be a vertical translation up. So I'm dealing with these 3 things, the first 3. A horizontal translation, a vertical translation, and a reflection. Let's go ahead and graph them. I'll use a graphing calculator here. So f of x, let's do the parent function, f of x equals, the fourth root. Let me get my root button. Fourth root of x. There's the parent function right there, the fourth root of x. All right, let me copy and paste this and make the child now. The child, so the parent's in black, the child is going to be in red. Let's put the negative in front of it, right? Look at, there it is, reflection over x-axis already. I could see it's already reflected, flipped over the x-axis. What else is there? Let's go back over here. What else was there? There was a subtraction of 1, right? So I already put the negative there. Now I'm going to subtract 1 inside the symbol. Boom. Oh, so I already see then it's a shift of 1 unit to the right. Notice that. We shifted it 1 unit to the right. That's what the subtracting 1 does. It takes it to the right. And then what else we got? We added 3. Let's add 3. Outside the radical symbol. So add 3, rock, and then roll in. So we flipped it over the x-axis, horizontal shift to the right 1 unit, and then vertical shift up 3 units. So we flipped it over the x-axis, move it to the right 1 unit, and then moved it up 3 units, notice. Okay? 3 units. Let me make it, there we go. So we flipped the parent over the x-axis, moved it to the right, then up 3. So let's describe, that's 3 sentences here. Excuse me. Here we go. Reflection over the x-axis first thing, right? That's right here. Just follow your note guide. Okay, that's a reflection over the x-axis. Okay, it's a reflection over the x-axis. And the next thing was, I'm going to describe the -1, the subtracting 1, right? That's a horizontal shift, 1 unit to the right. And then there's a vertical shift. I'm going to describe now the 3 outside the fourth root symbol. That's a vertical shift now. Vertical shift, 3 units up. All right, go and do your flip grid now.